Let's talk about how does XSS work. Cross-site scripting works by manipulating a vulnerable website so that it returns malicious JavaScript to users when the malicious code executes inside victim's browser. The attacker can fully compromise their interaction with the application, like password, sensitive data, wire transfer, etc., with writing the script in the URL part. Also here you can see in the Portswigger labs, there are the 9 labs for the easiest label where you can do some practice. You can confirm most kinds of XSS vulnerability by injecting a payload that causes your own browser to execute some some arbitrary JavaScript. It's long been common practice to use the alert in the brackets function for this purpose because it's short, harmless, and pretty hard to miss when it's successfully called. In fact, you solve the majority of our XSS labs by invoking alert in a simulated victim's browser. As I say, first 9 labs. Unfortunately, there is a slight hitch if you use Chrome. From version 92, cross-region iframes are prevented from calling this script, as these are used to construct some of the more advanced XSS attacks. You sometimes need to use an alternative payload. In this scenario, we recommend the print function. If you are interested in learning more about this change and why we like print, check out the blog post. In the blog post, you will find the information, the newest information. As I talked before, there is 3 types of the XSS attacks. It's reflected, stored, and DOM-based. Here the example of the reflected cross-site scripting. Reflected XSS is the simplest variety of cross-site scripting, where you can just write this kind of scripts. The application doesn't perform any other processing of the data, so an attacker can easily construct an attack like this. If the user visits the URL constructed by the attacker, then the attacker script executes the user's browser. In the context of that user session with the application, at the point the script can carry out any action and retrieve any data to which the user has access. Also, stored XSS attack. Here, the simple example of stored XSS vulnerability, a message board application with the hello, this is my message. The application doesn't perform any other processing of the data, so an attacker can easily send a message that attacks other users. Bad stuff here or something like this. DOM-based cross-site scripting. Also, here you can see the scripts, how it works. What can XSS be used for? An attacker who exploits a cross-site scripting vulnerability uses this XSS for impersonate and masquerade as the victim user, carry out any action that the user is able to perform, read any data from the user's browser, capture the user's login credentials, perform virtual defacement of the website, inject Trojan functionality into the website. Impact from the XSS. The actual impact of XSS attack generally depends on the nature of the application, its functionality in the data, and the status of the compromised user. For example, in a browserware application where all users are anonymous and all information is public, the impact will often be minimal. In an application holding sensitive data, which has banking transactions, emails, or healthcare records, the impact will usually be serious. If the compromised user has elevated privileges within the application, then the impact will generally be critical, allowing the attacker to take full control of the vulnerable application and compromise all users' data. The next question is how to find and test for XSS vulnerabilities. The vast majority of XSS vulnerabilities can be found quickly and reliably using Burp Suite's Web Vulnerability Scanner. Manually testing for reflected and stored XSS normally involves submitting some simple unique input, such as a short alphanumeric string, into every entry point in the application, identifying every location where the submitted input is returned in HTTP responses, and testing each location individually to determine whether suitably crafted input can be used to execute arbitrary JavaScript. In this way, we can determine the context in which the XSS occurs and select a suitable payload to exploit it. Manually testing for DOM-based XSS arising from URL parameters involves a similar process, placing some simple unique input in the parameter using the browser developer tools to search the DOM-based for this input and testing each location to determine whether it's exploitable. However, other types of DOM XSS are harder to detect. To find DOM-based vulnerabilities in non-URL-based input, such as document cookie or non-HTML-based things, the set timeout, there is no substitute for reviewing JavaScript code, which can be extremely time-consuming. Burp Suite's Web Vulnerability Scanner combines static and dynamic analysis of JavaScript to reliable automate the detection of DOM-based vulnerability. Let's widely explain how to prevent XSS. In this part, I will describe some general principles for preventing cross-site scripting. You also in Portswigger learning path find some useful information for your self-study. Cross-site scripting prevention can generally be achieved via two layers of defense. It's encode data on output and validate input on arrival. You can use Burp Scanner to scan your website for numerous security vulnerabilities, including XSS. Burp's cutting-edge scanning logic replicates the actions of a skilled attacker and is able to achieve correspondingly high coverage of XSS vulnerabilities. You can use Burp Scanner to gain assurance that your defenses against XSS attacks are working effectively. Encode data on output. Encoding should be applied directly before user controllable data is written to a page, because the context you are writing into determines what kind of encoding you need to use. For example, values inside a JavaScript string require different type of escaping to those in an HTML context. In HTML context, you should convert non-whitelisted values into HTML entities, like this symbol converts this kind of, this symbol converts this kind of. In a JavaScript string context, non-alphanumeric values should be Unicode escaped, like this encodes this one. Sometimes you'll need to apply multiple layers of encoding in the correct order, for example, to safely embed user input inside and deal with both the JavaScript context and the HTML context. So you need to first Unicode escape the input and then HTML encode it, like this. Also, we have a validate input on arrival. Here, if user submit URL that will be returned in response, validating that it starts with a safe protocol such as HTTP or HTTPS. Otherwise, someone might exploit your site with a harmful protocol like JavaScript or data. If user supplies a value that is expected to be numeric,